In today's lecture, let's review decimals and real numbers. In the first part, let's convert each of the following rational numbers to the form a over b, where a and b are integers, and b not being equal to 0. For question 1, this is 0.34. We could write it as a fraction. This is pronounced 34 hundredths, so I could rewrite this as 34 over 100. But notice how the numerator and denominator still have a common factor of 2, so let's divide the top by 2 and the bottom by 2, and this is equivalent to 17 over 50. So this is our fractional form for 0.34. For question 2, it's very similar. I look at the decimal places. This has 3 decimal places to the right, so this is 2 and 206 thousandths. So I could rewrite this as 2,206 divided by 1,000. So I'm just looking at how many places I need to make this a whole number. I need to move the decimal place 3 times to the right. So that's why I'm dividing by 1,000. I need 3 zeros. And if you're unsure, use a calculator. Divide 2,206 by 1,000 and you should get 2.206 back. Now let's check for a common factor. Let's divide the top and the bottom by a common factor. Again, the common factor here is 2, so let's divide the top and bottom by 2, and I get our solution is 1,103 over 500. In question 3, we have 0.9 bar. 0.9 bar is equivalent to 0.9999, and the 9 repeats forever. So what we're going to have to do is convert this to a fraction, but it's more difficult since we have these repeating 9s. So I'm going to use a little trick. Let's let x be equal to 0.999 repeating forever. And then I want to figure out a way to get rid of all these repeating decimals. I'm going to start by multiplying both sides by 10. So on the left, you're going to get 10x. On the right, what happens when you multiply by 10? The decimal is going to move 1 time to the right here, and that's equivalent to 9.9999. And these 9s are still going to continue to repeat forever. Now we have an opportunity to get rid of all of these repeating 9s. Notice in x we have repeating 9s, and in 10x we have repeating 9s. What I want to do next is to subtract x on the left side. So that's 10x minus x on the left. On the left, I subtract x. On the right, I'm going to subtract x also, but I'm not going to use x. I'm going to use the decimal form. So we have 9.999 repeating, and I'm subtracting 0.999. Again, this is equivalent to x. So I subtracted x on both sides. On the left, we used x. On the right, we used the decimal form for x. Now what happens? Look carefully. On the left, we have 9x. On the right, all of these 9s are going to cancel out. That's what we want. So this is equivalent to 9. Let's divide both sides by 9, and x is equal to 1. Now, isn't that surprising? What we're trying to say is 1 is equivalent to 0.9999. That's what we're trying to say. 1 is equivalent to 0.999 or 9 bar, which is a pretty amazing thing. It is pretty amazing and pretty weird at the same time, but it's true. 1 is equivalent to 0.9 bar. In question 4, we'll use the exact same strategy. 0.5 bar is equivalent to 0.555, and the 5s are going to repeat forever. I will let x be equal to 0.5555, and it repeats forever. And we'll multiply both sides by 10 again. That's 10x equals 5.555, and these 5s will repeat forever. When we multiply both sides by 10, again, this decimal place moves to the right one, and that's why I have a 5 here in the front. To get rid of all of these 5s, we'll subtract x on both sides again. So 10x minus x is equivalent to 5.5 repeating. Minus, now we're going to subtract x in the decimal form, which is 0.555 repeating. And again, what happens to those repeating 5s? They cancel out. On the left, I have 9x. And on the right, all of these repeating 5s, they cancel out. We just get left a 5. I can divide both sides by 9. And x equals 5 over 9. This is the fractional form for 0.5 bar. And if I'm not sure, use a calculator and you should get repeating 5s. In question 5, we'll use a similar strategy, but we'll have to change it up slightly. In part 5, we have 0.32 bar, which means the 3 and the 2 are going to continue to repeat. So this is equivalent to 0.323232, and those 3 2's are going to repeat forever. Now I'm going to let x be equal to this decimal number, 0.323232, repeating forever. And instead of multiplying both sides by 10 like we did earlier, we want to cancel out the 3 2's, so I actually need to move the decimal place twice. So instead of multiplying both sides by 10, let's use 100. Let's multiply both sides by 100 instead. 100x equals 32.323232, and of course these 32's are going to continue to repeat. Next is to get rid of all these repeating 32's, so we'll subtract x on both sides. 100x minus x is equal to 32.32 repeating. And we're going to subtract the decimal form just like we did earlier. That's 0.323232 repeating. And you can clearly see that the decimals will disappear. These decimals will cancel out. So I have 99x on the left equals 32. Let's divide both sides by 99. And so x equals 32 over 99. This is our fractional equivalent. And if you're not sure, check it out on a calculator. You'll see that this is correct. In question 6, we have 0.32 bar, which means only the 2 gets repeated forever. Not the 3, only the 2 gets repeated forever, since the bar is only over the 2. We'll use a similar strategy. Let's let x be equal to this decimal number. And now I want to get it so that the 3 is in front of the decimal because I want to cancel out these repeating 2's. So let's multiply both sides by 10. I'll get 10x equals 3.2222, and the 2 repeats forever. Now we could subtract both sides by x, but then this 2 will not cancel out with this 3. So instead, I'm going to have to try something else. Let's multiply it again by 100. So let's multiply x by 100. I get 100x. And on the right, if I multiply this by 100, I would get 32.22 repeating. And this is great. This is great because the 2's now have a good chance of canceling out with these repeating 2's. So let's start with 100x and we'll subtract 10x from it because these 2's will cancel out with each other. we have 100x minus 10x on the left, and on the right it's 32.222 repeating, minus the 10x, which is right here, 3.222 repeating. And you will see that all of these repeating 2's do cancel out. That's exactly what we want. We have 90x on the left, and on the right it's 32 minus 3, which is just 29. Let's divide both sides by 90. Our fractional equivalent is 29 over 90. In this problem, we had to do more work than the other ones, but it's very similar in technique. So please try these again on your own. In this question, we want to rewrite the following decimal numbers in ascending order, which means from the smallest to the biggest. So we want to write it from the smallest to the biggest. And the best way to do this is to make sure they have the same number of decimal places. I can see here this has 3 decimal places, some have 1 decimal place, some have 2 decimal places. So we want to make sure we have the same number of decimal places. I'll start off with 2.3, and I can rewrite that as 2.300. Now this has 3 decimal places. I can compare that now to 2.345 bar, which is equivalent to 2.34545. Now, of course, it continues on forever, but notice we have 5 decimal places here for the second number, so I'm going to add additional zeros here so we have 5 decimal places. And that will allow me to compare these two. I'm going to write the other number here, 2.345 bar. 2.345 bar, the bar is on top of the 5. So this is equivalent to 2.34, and the 5's are going to repeat forever. The next number is 2.345. This is equivalent to 2.345, and we'll add 2 more zeros just so we can compare it with everyone else. 2.34 is equivalent to 2.34, and we'll add 3 zeros to compare it to everything else. 2.134 is equivalent to 2.134 with 2 more zeros added. And finally we have 2.534. And we'll just add 2 more zeros to this number. Now we can rewrite the following from smallest to biggest. The smallest number here is this number, so we'll write 2.134 first. The next smallest number is 2.3. The next number is 2.34. Then we have 2.345. Then we have 2.345 bar, followed by 2.345 bar. And the largest number is 2.534. So this is our arrangement in ascending order. Question 2. Without using a calculator, convert each of the following fractions to decimals that either terminate or repeat. So let's figure out how to do this. We have 7 over 15. To convert a fraction into a decimal, we'll use long division. Let's divide 15 into 7. Now 15 does not go into 7, so I'm going to put a 0 in front of my decimal and add an additional 0. How many times does 15 go into 70? Well, it goes in there 4 times. 15 times 4, that's 60. We'll subtract. I get a remainder of 10. 15 does not go into 10, so that's good. We know we did it right. So we're going to bring down another 0. and ask how many times does 15 go into 100? Well, it goes into 100 6 times, and 6 times 15, that's 90. I get a remainder of 10, and then we're going to continue to add another 0. 15 goes into 100 6 times, and you should be able to see the pattern by now. Let's just do it a couple more times just to make sure. 15 times 6 is 90. Subtract, we get another 10. Drop down another 0. It's going to become 100 again. So this is another 6. So we can say 7 over 15 is equivalent to 0.466, repeating. Or I can say 0.46 bar on top of the 6. Please pause the video and try part B on your own. Hopefully you tried part B on your own and you did not use a calculator. Remember, you're not supposed to use a calculator for this question. Let's put the 50 on the outside, the 11 on the inside. 50 does not go into 11, we'll put a 0. And then we'll add an additional 0. How many times does 50 go into 110? Well, it goes in there twice. 2 times 50 is 100. Subtract, I get a remainder of 10. Let's bring down an additional 0. How many times does 50 go into 100? Well, it goes in there twice. 2 times 50 is 100. And we get a remainder of 0. 11 over 50 is equivalent to 0.22. This is a terminating decimal. It does not repeat like in part A. In part 3, let's perform each of the operations in problems 1 through 8 by changing the decimals to fractions first, and of course we'll have to show all our work. Let's look at this example. 0.3 plus 0.54 is equivalent to 3 over 10 plus 54 over 100. We can make sure the denominators are the same, add the numerators together, and then convert it back to a decimal. So that's not too bad of a strategy to do, so let's try it for question 1. In question 1, I can write 0.5 as 5 over 10, and 0.72 can be rewritten as 72 over 100. Again, I can figure out how many zeros I need by looking at the decimal places. And we can multiply the top and bottom of the left fraction by 10. That's 5 times 10, which is 50 on the top, and 10 times 10 is 100 in the denominator. Since the denominators are the same, we can add the numerators. 50 plus 72 is going to be 122 over 100, and 122 over 100 is equivalent to 1.22. Now, why do we spend all of this work converting from decimals to fractions and then back to decimals? Well, you're going to be teaching students the relationship between decimals and fractions. In question 2, let's convert 0.21 into a fraction. That's 21 over 100. And 0.315, I'll need 3 zeros for this. That's 315 over 1,000. We need to get the denominators the same, so let's multiply the top and bottom of the first fraction by 10. That's going to give me 210 over 1,000 plus 315 over 1,000. And now I can easily add the numerators. 210 plus 315 should give me 525 over 1,000. And that's equivalent to, let's divide by 1,000, that's 1, 2, 3. So I should get 0.525. This is our solution for question 2. You're welcome to pause the video and try the rest on your own. It's pretty similar to each other. Let's go over the solution for question 3. I can convert this to a fraction. That's 98 over 100 minus 7 over 10. Let's multiply the top and bottom of this fraction by 10. That's 98 over 100 minus 70 over 100. So subtraction is the same as addition. This becomes 28 over 100, which is equivalent to 0.28. In question 4, let's convert 0.273 into a fraction. That's 273 over 1,000 minus 1 over 10. We need the same denominators here, so let's multiply the top and bottom by 100. And this will give me 273 over 1,000 minus 100 over 1,000. 273 minus 100 is 173 over 1,000. And of course, in decimal form, that's 0.173. You can always double check any one of these with a calculator, but remember, you gotta show your work to get full credit. In question 5 and 6, we're gonna learn how to multiply decimals. Let's convert 0.8 into a fraction. That's 8 over 10, and we're gonna multiply that by 0.7, which is 7 over 10. To multiply fractions, you just multiply straight across. 8 times 7, that's 56. And 10 times 10, that's 100. Well, 56 over 100, that's 0.56. Now, isn't that a lot quicker than stacking these fractions up? I think so. Let's try question 6. 0.11 is 11 over 100, and we're going to multiply that by 0.22, which is 22 over 100. 11 times 22, what is that? That's equivalent to 242, and 100 times 100 is equivalent to 10,000. If I divide 242 by 10,000, I need to move this decimal 4 times to the left. That's 1, 2, 3, 4. That's 0.0242. So in some ways, converting it to a fraction is a lot easier than actually multiplying it out. Let's see how division works. For question 7, we have 9/10 divided by 3/10. Well, to divide fractions, we got to keep the first fraction the same. Change this to a multiplication. Flip it over. So that becomes 10 over 3 now. The 10s, they divide out. And this is 9 over 3, but that's equivalent to 3. So this is pretty quick with fractions. One more question, question 8. Let's convert this to a fraction. That's 25 over 100 divided by 5 over 10. Again, I'm going to keep the first fraction the same. Change this to a multiplication and flip this over. That's 10 over 5. Let's see if you can reduce first. I can reduce the 10 to a 1, the 100 to a 10. 5 reduces to a 1, and the 25 reduces to a 5. So we have this is equivalent to 5 over 10, or 0.5.